A very good day to all. I welcome you all for this lecture series on manufacturing technology. So, in this particular video, we'll be discussing about forging and rolling process. So, the previous video we discussed about the hot working and cold working process. So, metal working process we have discussed in the previous video. So, this is a continuation of that video. We'll be discussing in detail about the forging and rolling process. Let's get into the topic. So most of the components which we see around us, so any component which has a load bearing application will be made using metalworking process only. So just to give you a quick recap, so any load bearing structure around us will be made from metal structure will be made from this metalworking process. Reason being, when manufactured using metalworking process, the grains will be realigned. Either new grains will be formed or existing grains will be deformed so that their mechanical properties are enhanced. So that's the reason why we are going for this metalworking process. So one of the most important metalworking process is forging. So if you have to make a shape of component with a particular shape, you can go for forging process. So example of components made from forging is, as you can see in that image, the hammer which they are using. Hammer itself will be made from forging process. Spanner, which is used for torque, twisting, screwdriver. Any tool you take, it will be made from forging process. Reason being, the tool has to withstand certain twisting force as well as pull force. If it's a hammer, it has to withstand the shock. If it's a spanner, it has to withstand the twisting force. So that force, in order to retain it, in order to withstand that force, it has to have mechanical properties, enhanced mechanical properties. It should have better strength, better toughness, better stiffness. So that property can be incorporated into metal using this forging process. So forging is a process which is made by hammering the component. So there are various types of forging process. Two main categories: open type forging and closed type forging. So forging involves pressing the component with help of a hammer or with the help of a press. So we'll see what are the different types of forging. So as you can see, this one is called as open type forging. So if you see the image closely, the component here is glowing hot. So from this image, we can understand that this is a hot forging process. So hot forging is a process which is done above the recrystallization temperature. The forging is done below recrystallization temperature. It is called as cold forging. So this particular forging is called as open die forging because the die is flat in nature. So flat die can be used for manufacturing cylindrical, square, rectangular cross-sectioned components. So those components can be made using this open die forging. So what it indicates is that here the shape of the component will not be predefined. So you can make a rough outline of the component using this open die forging. Large components can be manufactured using this open die forging. The process is mentioned here. So next type of forging is closed die forging. So if you see the difference between these two images, the die here is actually shaped according to the final shape of the component required in closed die forging. Whereas in open die forging, the die will be flat in nature. So here, the component which you have to make will be impressioned in the die itself. For example, if you are making a spanner or you are making a sheet, then that shape of that spanner will be impressed in the die itself. So once the component is pressed using this die, the component shape will be the shape of the die will be imprinted in the final output product. So here there is a since the shape is being pressed here, as you can see in the third image, there will be metal protruding from outside. So that excess material is called as flash. So flash is nothing but excess material protruding from the finished component. In the casting process, there will be some projection of runner, projection of riser will be around the final product, which we will be cutting out and removing. Similarly, here there will be projection of metal protruding from the component, so that can be removed with the help of machining process. Secondary machining can be done to remove that process. So that excess material is called as flash. So as I said, the process can be done by various techniques. One is by using hammer, other is using by press. Small components are produced. For example, knife or a sword, it can be manufactured using hammer itself. Handmade products will be made using hammer. Whereas if you go for larger components or mass production, you can use dies and punches. So here, forging is done using a hydraulic press, as you can see here. Hydraulic press operates with the help of fluid oil, liquid. So the process is done with the help of liquid pressure. It is called as hydraulic process. If it is done with the help of air, it is called as pneumatic process. So here is the hydraulic process. As you can see, the piston cylinder arrangement is provided to provide the pushing force needed. So there are different types of press available: mechanical press, hydraulic press, and pneumatic press. So among these three, hydraulic is more reliable. Mechanical press will be giving the force with the help of gear assemblies, and pneumatic press will be using the same hydraulic method, but here instead of the working fluid will be air instead of oil. In hydraulics, you will be using liquid as the medium, whereas in pneumatic, you will be using air as the medium. So that's a major difference between these two processes. So I hope you understood the forging process. Forging is making an impression of the object which we have to make. So I have listed the components which can be manufactured in forging. So those are the examples. The next process is rolling. So rolling is predominantly used for manufacturing sheets, sheet metal. You would have heard sheet metal sheets. So those components can be manufactured using the rolling process. So in your class, you'll be sitting in a desk. So desk is made up of sheet. So if you see around you, the desk will be made from sheet metal. So sheet metal is nothing but any component having any plate having thickness less than 6 mm is called as sheet metal. So you will be confused sometimes. Sometimes you'll be calling metal as plate, sometimes you'll be calling it as sheet. So the thickness is less than 6 mm, it is called as sheet. The thickness is more than 6 mm, it is called as plate. So rolling can be employed for manufacturing both sheet metal as well as metal plates. So rolling is predominantly done with the help of rollers. As you can see in this image, rollers can be used for making the rolling process. So here, as if you watch the image closely, so initially the bloom will be having larger grains, but once it passes through the roller, as you can see, the grains are elongated. The grains are elongated because the rolling process flats down the grains. So from this image itself, you can understand that this is a cold rolling process because grains are elongated, not realigned. If it is a hot rolling process, then new grains would have been formed, smaller grains would have been formed. So this is actually an image of cold rolling process. So there are various cold stand arrangements available. 2 high rolling mill, 3 high rolling mill, 4 high rolling mill, tandem rolling mill, planetary rolling mill, like the different rolling mill arrangements are available. So based on the thickness of the sheet required as well as the initial size of the billet, the rolling mill stand arrangements can be differed. So there are, as you can see, tandem rolling mill, planetary rolling mill. Different rolling mills are employed depending upon the thickness of the output thickness required. If you see the tandem rolling mill, the thickness will be very, very thin output. Output sheet will be very, very thin in nature. Whereas if you compare with the planetary rolling mill, it will be somewhat bigger. So from the initial size to the final size, the ratio will determine the type of rolling mill which you are employing. If the smallest thickness is required, you have to go for bigger rolling mills. 2 high rolling mills can be used for manufacturing. The billet to final output ratio is smaller, thickness ratio is smaller, then you could go for 2 high rolling mills. So that's regarding rolling stand arrangements. So rolling, as mentioned in forging, open die and closed die forging. Similarly, rolling can be employed for manufacturing sheet as well as shape rolling can also be done. So if you see this image here, this is similar to closed die forging. Here, the rolling mills itself, the rolling mill roller itself will have dies that as required for the output component. The output component shape will determine the shape of the roller. So in the above image, those red images indicates the output sheet which we can obtain from this rolling mill. So it can be used for manufacturing different cross-section plates also. So that's regarding this rolling and forging process. I hope you understood today's lecture. To give a quick recap, we discussed today about forging and rolling process. So forging is used for manufacturing components which are used for load bearing applications. So there are two types, open die forging and closed die forging. Similarly, rolling is used for manufacturing of sheets and plates. So both these processes can be majorly classified into hot extrusion, cold extrusion. Similarly, hot rolling and cold rolling. So depending upon the temperature at which the process is done. The process is done above the recrystallization temperature, it is a hot working process. If it is done below recrystallization temperature, that is the cold working process. So I hope you understood today's lecture. We'll see in yet another lecture video. Thank you.